Hi students, this is the next topic in the lesson Physical World and Measurement, that is dimensional formula. The previous lesson we discussed about fundamental units and derived units. And fundamental units, the basic units are, the one is mass. The dimension for mass is given capital M. Okay? This M represents dimension of the base quantity, the fundamental unit. And the dimension for length is given capital L, is the dimension of length. And dimension of the fundamental unit time is given capital T. The previous class we learned about fundamental physical quantity and derived physical quantity. The fundamental physical quantity which can be measured and expressed independently. For example, mass we can measure by using a weighing balance, and you can write mass M equal to the value. There is no need of any equation for measuring mass. Length can be measured directly by using a ruler, and you can represent length also independently, no need of any equation. Time also we can measure by using a watch or a timepiece, and it can be expressed independently without any equation. But the physical quantities like force, you cannot measure force directly. First of all, you have to measure the mass, then acceleration, then multiply both of them. So they are called derived quantities. And these fundamental physical quantities, that can be measured directly and expressed independently, that is mass, length and time, they have given the base dimension. Mass is given capital M, length L and time T. So dimensional formula of a physical quantity means how and which of the base quantities represent the dimension of a given physical quantity. How and which. How means in what power the base quantities are present in a given physical quantity. How and which of the base quantities are present. Which of the base quantities are present in the dimensional formula of a given physical quantity. That represents dimensional formula. How and which of the base quantities are present in the dimension of a given physical quantity. That gives the dimensional formula of a given physical quantity. For example, a simple example, suppose we are taking area. In case of area, you know that equation for area is length into breadth. Length into breadth. Okay. Length is measured in meter. It has a dimension capital L. Breadth also same. It is measured by using a ruler. That also capital L. The dimensional formula of area. Dimensional formula usually we write in a square bracket. It is L square. L square is the dimensional formula of area. L into L, length into breadth. Or we can write in complete form. In dimension of area, mass is not there, so we can write mass m raised to 0. L is there with the power 2, and time is not there, so t raised to 0. This is the complete form of the dimensional formula of area. Got it? Next example. If you take volume, dimensional formula of volume, we know that volume equation of volume is LBH, length into breadth into height. Okay? But all these three are measured by using a ruler. All are measured in meter or centimeter. Means all are length only actually. So we can write that is L into L into L. Okay, L, length is in meter, breadth also in same meter, height also in the same meter. So we can write the volume has a dimension L cube. There is no mass in this and there is no time in this. So the complete form of dimensional formula of volume we can write down. Dimensional formula of volume is equal to, there is no mass in that, so we'll write m raised to 0. Length is with the power 3 and time is not there, so t raised to 0. This is the dimensional formula for volume. Okay. The next one, dimension for, suppose, speed. Dimension of speed. Speed is given by distance by time. So the dimension of distance is L. It is measured in meter, L. and dimension of time is capital T. Okay, so it can be written as L into T raised to minus 1. L into T raised to minus 1 means there is length with the power 1, time with the power minus 1. There is no mass in this one. So once again we can write speed dimension is, dimensional formula of speed can be written as m raised to 0. There is no mass, but length is with the power 1, time is with the power minus 1. So m raised to 0, L T raised to minus 1 is the dimensional formula of speed. Got the idea? The same way we can find the dimensional formula of any other physical quantity if you know the equation. If you know the equation, we can find out the dimensional formula of any other physical quantities. For example, next one is force. So force usually we need in almost all expressions. So we'll write the force equation is force is equal to F is equal to ma, mass into acceleration. So to get the dimension of force, we need dimension of mass and dimension of acceleration. So first of all, dimension of mass is capital M. Mass dimension is capital M. And acceleration we have to find out. Equation for acceleration is, you know, acceleration is equal to this change in velocity by time. You remember the equation from 9th standard. Acceleration is final velocity minus initial velocity by time. Or here we'll write this change in velocity as delta V. Delta always stands for a change, a small change. Change in velocity by time is acceleration. And for dimension of acceleration, dimensional formula of acceleration, we can get from dimension of velocity by dimension of time. Dimension of velocity is displacement by time. Speed and velocity has same dimension. Speed is distance by time, velocity is displacement by time. Displacement also is in meter, time in second. So the dimension of speed and velocity are same. Both speed and velocity are length by time. So both are having same dimension, L T raised to minus 1. So here dimension of acceleration we can obtain from dimension of velocity, that is displacement by time means meter per second means length into time raised to minus 1 divided by time is there. T is there at the denominator. Time is having dimension capital T. This T can be taken to numerator as T raised to minus 1. Then T raised to minus 1 plus minus 1 come T raised to minus 2. It will give T raised to minus 2. So we can write the dimension of acceleration is L T raised to minus 2. L T raised to minus 2. Now we can get the dimension of force. Dimension of force we can obtain by using dimension of mass and acceleration. That is dimensional formula of force. We can write in square bracket. Dimensional formula of force F is equal to dimension of mass is capital M and dimension of acceleration L T raised to minus 2. So this is the dimensional formula for force, MLT raised to minus 2. Means in this equation we can see in force mass is present with the power 1, the base quantity, the fundamental quantity mass is present with power 1, length is present with the power 1 and time is present with the power minus 2. So this represents a dimensional formula. Dimensional formula of force is MLT raised to minus 2. Dimensional formula of a physical quantity is an expression which represents how and which. How means with what power it is present, and which of the base quantities are present in the dimension of a given physical quantity. That expression is called a dimensional formula. In exam you may get question to find out the dimensional formula of different physical quantities. What is the dimensional formula of gravitational constant? What is the dimensional formula of torque? What is the dimensional formula of coefficient of viscosity? So you must know the basic equation of these quantities, then we can find out the dimensional formula. I'll give one more example for dimensional formula of what is called the universal gravitational constant. You can find out the dimensional formula of universal gravitational constant. So you can write down the question, find the dimensional formula. Find the dimensional formula of gravitational constant, that is universal gravitational constant capital G. All of you know the equation for gravitational force from Newton's law of gravitation, that is F is equal to force between two objects, two bodies, is equal to G into m1 mass of one body, m2 mass of the other body, divided by square of the distance r square. This is the equation for gravitational force you studied in 9th class. Now here we need to find the dimension formula of G. So we'll rewrite this equation as G is equal to F into r square. This r will go to here, F r square divided by m1 into m2 equal to G, or G is equal to F into r square divided by m1 into m2. So the dimensional formula of G, the universal gravitational constant G, is equal to dimension of force. Dimension of force already we obtained here, ml t raised to minus 2, that we can substitute here. Dimension of force is ml t raised to minus 2, into r means distance between the center of two bodies, that means length only. So r is length, it is expressed in meter, so square of that, and divided by m1 into m2, that is mass into mass. Mass into mass means m is the dimension of mass, again m is the dimension of m2 also, means m square is there, 1m will get cancelled here, this is cancelled, okay, and 1m will go to numerator as m raised to minus 1. So this m will go to numerator as m to the power minus 1, m raised to minus 1. Then here we have L and here L square, so L cube, L into L square become L cube, and t raised to minus 2. This is the dimensional formula of universal gravitational constant. It means the dimensional expression of universal gravitational constant, there is mass with the power minus 1, length with the cube, and time with the minus 2 power. Okay, so this way you can find out the dimensional formula of any physical quantities if you know the equation of that. So all of you write down the homework. First question number 1, find the dimensional formula of pressure. Second question, find the dimensional formula of momentum. You remember momentum is what? Mass into velocity. Momentum. Third question, find the dimensional formula of work. Find the dimensional formula of these three quantities. In the next live class, you must tell me the answers of this. Okay? Thank you.